Welcome back, Caymans. Mr. Eicher here, taking a look at this second part of this lesson about chapter 15, lateral surface areas and volume. So let's check out a cylinder. And the question says, find the lateral area and surface area of the solids below. And then at the very bottom, we'll also find the volume. So with the lateral area and surface area, you have formulas above in your notes. But just again, to explain where these formulas come from, if you were to cut this cylinder right down the side like that and unravel it, you would see something that looks like this. You'd see a rectangle if you unpeeled it like that. And then you'd have, the bottom circle, and then you'd have the top circle. I have to figure out where to put this. I'll put it over here, I guess. That's what it would look like. So when we ask about finding the lateral area is this green area in here. So what is that area? Now that area would be the height of the cylinder, which above the height of the cylinder is 4. And then this distance, this length of the rectangle, would be the circumference of the circle. That's the part that would wrap around the circles to form the cylinder. So the circumference of the circle is 2 times pi times the radius. 2 pi r. Circumference is 2 pi r. Or you could talk about circumference as pi times diameter. Diameter would be 2 times r, so 8. So the area, the lateral area, would be 8 pi times 4, so that would be 32 pi. Would be the lateral area of this cylinder. So lateral area we'll call 32 pi. And the units, it's an area, so that would be square inches. I'm going to leave it in terms of pi, so we will probably ask you to leave it in terms of pi. That prevents different problems with having to do rounding and things like that. So 32 pi. If you type that, that would be 32 pi, 32 pi with no space or anything. Okay, and then the surface area. The surface area would be these two circles plus all the stuff that we just found inside there. So the surface area, from the formula above, it's the lateral area plus 2 times the base. The lateral area we just found, which is 32 pi. Whoops, not 33, 32. Plus the area of one of these bases. The area of one of those bases, well, it's a circle, so pi r squared. So that would be pi times 3 squared. So this area is 9 pi, and then this area is also 9 pi. So we'd have 2 times 9 pi. So adding these up, we'd have 32 pi plus 18 pi. That would be 50 pi. So our surface area would be 50 pi. And again, that would be square inches because it's the area. And then lastly, the volume of the shape. The volume of the shape would be the area of the base, which is pi r squared, times the height of the cylinder, which is 4. So 9 times 4 is 36, and then tack on a pi. The units there would be cubic inches, 36 pi cubic inches. One note to make is that the surface area should always be bigger than the lateral area. Since the surface area is the lateral area plus some more, the surface area should always be bigger than the lateral area. So you could always, a quick double check. That doesn't mean you have to get it right if the inequality is right, but at least it warns you that if your surface area is less than your lateral area, then maybe you flip-flop them, or maybe you did some miscalculation. All right, let's look at this cone now. Now for a cone, the lateral area is the part that wraps around. So the part that wraps around the cone is the lateral area. And to calculate lateral area, we use the formula pi r L, and L is the slant height. So this 5 right here is L. The radius is identified as 3. And eventually we'll want to find this height of the cone. So how about we just do that now, since we're going to need it eventually anyway. So we have, notice, a right triangle where the radius is 3. The slant height is 5, and we're looking for the height of the cone. And it is a right triangle. Well, we can always assume in this course that it's a right triangle. The height should be perpendicular to the base and meeting at the center of the circle. So to find that, we can use the Pythagorean theorem. H squared plus 3 squared equals 5 squared. This would be h squared equals 5 squared minus 3 squared. So h is plus or minus the square root of 25 minus 9. I don't really need the plus or minus. It's just the positive one because it's a height, so plus. And so that would be the square root of 16, which is 4. This is a really common, probably the most common Pythagorean triple, the 3, 4, 5 Pythagorean triple. So the height is 4. Height is 4. Now we didn't need that value. To find the lateral area, we're going to do pi times the radius, which is 3, times the slant height, which is 5. So we'd get 15 pi. So the lateral area is 15 pi, and the units would be, again, square inches. It's area, so it's squared units. Now to find the surface area would be the lateral area plus the base. Big B is the base. The area of the base is circle, so we would get 15 pi that we just found, plus the area of the base, pi r squared. Well, that would be 9 pi. So our area, our total surface area, is 24 pi square inches. 24 pi square inches. And I'll leave it as that. And again, the surface area is larger than the lateral area, so that confirms a little bit to me, at least, that I didn't do something drastically wrong. And then lastly, let's find the volume of the cone. So the volume of the cone from the formula is the volume equals 1/3 the area of the base times the height of the cone. That would be 1/3 the area of the base is pi r squared times the height. So that would be 1/3 pi, the radius is 3 squared. The height we found earlier, which is 4. So this would be 1/3 pi times 36, 9 times 4. So I want to just point out initially, I'm going to write it like this, 36 pi over 3. 1/3 times 36 pi is 36 over 3 pi. Because right here, we're asked, what do you notice about these two figures? Well, what I notice is that they actually have the same dimensions. The radius equals 3 in both, and the height equals 4 in both. And because they have the same dimensions, the volume of the cylinder is 3 times bigger than the volume of the cone. So if we simplify this, you could see this is 12 pi cubic inches, whereas this one was 36 pi cubic inches. So when you have the same dimensions, the cone is going to be 1/3 the volume, right? That's the formula, 1/3 the volume of a cylinder with the same dimensions. So that was finding the lateral area, the volume, and the surface area of a cone and a cylinder. In the next video, we'll look at prisms. Thanks for watching, and feel free to give me a thumbs up if you like this video.